In this video, we will discuss regarding the maximization problems in the chapter assignments. Now we have done that the problems of minimization are solved with the Hungarian method. So in some questions, you may find the problems related to sales, output, course coverage by a teacher, and the things that we want to maximize. So in such cases, how to deal with this maximization problem? The process of solving maximization problem is more or less same that we have done in minimization. Just one thing you have to do is, you have to just take the maximum element out of the entire matrix and subtract all the elements of the matrix from that maximum element. So what you have to do is, you have to just subtract the maximum element and all other elements. Just choose the maximum element out of the matrix and then subtract all the elements from that maximum element. The problem will be converted into a minimization problem, then you can solve it. Let us see this maximization questions with the help of one example. Now you can see this practical example in front of you. So this is the problem of assigning the courses to the teachers. You can see above courses have been given, on the left hand side professors have been given. So that the question says the courses have to be assigned to the teachers to maximize the education quality. So now we want to maximize the education quality. So if one professor has to be given one course, so now we have to give the assignments of courses to the professors. Now as our purpose here is to maximize the quality of education, so this is a maximization problem. So the first step of solving such problem is to convert the maximization problem into a minimization problem. And how we do that? We select the highest element from the entire matrix. Now you can see from this entire matrix, highest element I can see is 70. Now what we will do is, we will subtract every element from this maximum element 70. And then we will be reaching at a matrix that will be called a minimization matrix. Now if we want to create a minimization problem, course 1, 2, 3 and 4, then on the left hand side professors are there, professor 1, 2, 3 and 4. So now we will subtract all the elements from this 70. So 70 minus 60, 10. 70 minus 40 will be 30. 70 minus 60, 10, and this is going to be 0. So like this you will subtract every element from 70. Now 70 minus 20, 50, this will be 10, 20 and 0. Again same, 70 minus 20, 50, then 40, then 30, then 10. And in the last it will be 40, 60, 40 and 30. So like this, now our maximization problem has been converted from maximization to minimization. Now we have to move ahead with Hungarian method from this matrix. Now what we do is, first row reduction, then column reduction. Like this we will move ahead with all the steps. Now we will start with step number 2. After first step of just converting the problem into the minimization problem. Now we will move ahead with the second step. Now what you have to do is row reduction. Now look at this matrix. Row reduction, we have to choose the minimum element from each row. So first row has 10, 30, 10, 0. So minimum element is 0. So subtracting from the minimum element, we are going to get the same things. Same answers will be there. So 10 minus 0, 10, 30 minus 0, 30, 10 minus 0, 10 and then 0. Now in the second row also you can see the minimum element is 0. So again we will subtract 0 from each element in the row reduction step. Now in the step number 3, for the third professor we can see that the minimum element is 10 in this row. So subtracting 10 will be 40, 30, 20 and 0. And in the last row we can see from here the minimum element is 30. So we are going to subtract 30. This will be 10, 30, 10 and 0. Okay, now after doing the row reduction, the next step for us is going to be the column reduction. Now let us move to the column reduction step. Now this column reduction step will be our step number 3. Again, there are 4 courses and there are 4 professors. So now for column reduction, again we will be choosing the minimum element from each column. So here minimum is 10 in the first column. So subtracting all the elements from 10, we will get 0, 40, 30, 0. In the second column, I can see the minimum element is 10. So this will be 20, 0, 20 and 20. In the third column, again we can see the minimum element is 10. So it will be 0, 10, 10, 0. In the fourth column, I can see all are zeros. So it will be the same like this. So now after this step, we will move ahead with step number 4. For just applying step number 4, we have to copy this table again and the heading will be making assignments. So I am making the assignments in the same step. So for this, you have to choose the rows with single zeros. So in the first row, I can see there are 3 zeros. So no assignment I made now. In the second row, 2 zeros. I cannot make an assignment because I want the row with a single zero. Now in the third row, only 1 0 I can see. So I am putting assignment over here. So once I put assignment over here, all the corresponding zeros are going to be cancelled. In the fourth row, again I am having 2 zeros, so no assignment. Now I will start column wise. In the first column, 2 zeros, I cannot make an assignment. In the second column, see there is only 1 0, so I am making the assignment. So once you put assignment in this column, the corresponding 0 in this row should be cancelled. So there is no other 0, so no need to cancel. In the third column, again 2 zeros and then no assignment. In the fourth, we have already done, so there is not requirement. Again we can start row wise. Now see, here in the first row 1 and 2 are there. In the fourth row again 1 and 2 are there. Except that there is no other 0 that has not been either assigned or cancelled. In the column wise also we can see this and this, 2 zeros, no assignment. So 2 zeros, no assignment. So this is a case of tie also. So in such questions what we can do is we can give assignment to the first 0 and then we can cancel corresponding row and column zeros. So this is just an arbitrary method. So if I put assignment over here, so it means this row should not have any other assignment. Even this column also should not have any other assignment. So this problem comes when there is a type of situation, 2 zeros in the rows as well and the column as well. So now we have put the assignment. Now we are left with this. So again we can put assignment over here. So now we can see there are 4 professors, 4 courses. Now 4 assignments we have got. So it means that is the optimal stage. We required 4 courses, 4 professors, and then we have already got 4 assignment. Professor 1 has been given first course, Professor 2 has been given second course, Professor 3 has been given 4th course, and Professor 4 has been given the 3rd course. Now how we will just show the answer. So now how we have to show the answers. For showing the answer, we are going to write the professor and the course allotment. So which professor has been given which course? We knew that there were 4 professors in the question. 1, 2, 3, 4. Professor 1 has been given the first course. Professor 2 has been given the second course. Professor 3 has been given the 4th course. And Professor 4 has been given the 3rd course. Right? So now we have to see that where to locate the answer. Now you have to just see the answer in the original table that was given in the question. So in the question, the original table, we will see. If you will look at the original table and if you will see for the first professor and the first course, how much value was given? It was 60. So we are going to write here 60. So the efficiency, the quality, the rating, whatever data has been given. So it was 60. Now for the second, if you look at the second, again you will see it was 60. So just look in the original table, the maximization table, because our main purpose is to maximize the quality of education, effectiveness. So you have to look at the original table. In the third, for the third professor, if you will look at the fourth column it was 60, and for the fourth professor, if you will look at the third, it was 30. So in the last you have to just add all of them so that you can reach at the final conclusion. So it will be 210. So like this we can solve the maximization problem in the assignment.